Good morning, students. Welcome to the statistics class. Today, I am going to take another problem from frequency distribution and help you to understand about the frequency distribution more specifically. Okay, all these students, whatever I have sent to you the videos, they were all about univariate frequency distribution. Univariate means it is all about single variable, students. Single variable. Like the data was only about heights, the data was only about weights. So like that, when we have only heights and only weights, then it would be a univariate variable. And if you form a frequency distribution of univariate variable, then it would be called as a univariate frequency distribution, students. I hope you have understood this. So what is a univariate frequency distribution? This frequency distribution of a single variable or of only one variable, frequency distribution of one variable will be called as univariate frequency distribution. So in many situations, simultaneous study of two variables becomes necessary for us. Okay, simultaneous studies. That means we have to study together, right, of two variables. Like for example, if we have to classify data related to heights as well as weights, students, both together, we have to classify the data about heights and weights, or income and expenditure, together. Income is also one variable, expenditure also is another variable. Or we may speak about the age of husbands, okay, the age of husbands and the age of wives together. Okay, so these are some of the variables which are together, two variables. Income is one variable, expenditure is another variable, age is another variable, age of husband is another variable, age of wife is a one variable, height is one variable, weights is another variable. So like this, when it is important for us to classify the data into two variables like this, two variables together like this, then we have to understand one concept which is called as bivariate frequency distribution, students. Bivariate frequency distribution. What is this bivariate frequency distribution? Frequency distribution of two variables put together. Frequency distribution of two variables together. Frequency distribution of two variables together. We call this to be as a bivariate frequency distribution. So this is very important kind of study that we need to do it, students, is just because most of the problems, most of the problems or things that we are studying in our second PUC will be something related to two variables, students. So it is important for us to study about this two variables, bivariate frequency distribution, heights and weights together, income and expenditure together, age of husband and age of wives together. Like that, we have to form a frequency distribution, like in the form of a table, right, in the form of a table like this. What I am showing it to you here is that. So some class intervals on the x-axis, or the and we denote this to be as x for one variable as heights. Say for example, we start with the 10 to 20, 20 to 30, like this for heights. And then for weights, it would be something like, we start here in this and make columns like this. Okay, columns like 40 to 50 or 50 to 60, like this we make it, students. And we need to find the data. We need to find the data when the data is given to us, that the data which lies in this 40 and 50 and this 10 and 20, we need to mark, or we need to put a tally like this. Here we need to put a tally. So a data which is between 50 to 60 and 20 to 30, like that, we need to find a tally. So we need to form this kind of a table and then solve the then find the frequency distribution. Okay, so it will be more clear to you when we are doing it with taking a problem. So what we need to do it, students, we need to adopt some rules of classification. Appropriate class intervals are formed for both the variables. One may be discrete or the other may be continuous. Okay, it is not necessary that both should be continuous. One may be discrete, the other one also may be discrete. One may be continuous, one may be discrete. So if one variable is grouped as x, we denote it as x like this. The other variable we denote it as y. Okay, and these are all what we call it as cells. Okay, these are cells. These are like m rows, n columns, and these are all m into n cells we have. So we need to enter the data into those cells. So represent the class intervals corresponding to one variable in the first column of the table and class intervals corresponding to another variable in the first row of the table. So like that we need to do the tallies, and then we need to form a frequency distribution. Now once we form a frequency distribution of this type, when two variables are formed in the table like this, so if you want to find out and or you have to extract only one variable out. So for example, if you want to only find out the heights, only you want to make a frequency distribution of heights. So that frequency distribution will be called as marginal frequency distribution, students. Will be called as marginal. Understand? Okay. What is that marginal frequency distribution? In a bivariate frequency distribution, the frequency distribution of only one of the variables is considered. If only one of the variables, say for example, if I consider only y, then it is called as marginal frequency distribution. Or if I consider only x, then it will be called as marginal frequency distribution, students. If we put together in the table, it is bivariate. If you extract from bivariate distribution one of the variable, then it would be called as marginal frequency distribution, and that is what you need to understand. Okay, so I will take one problem to you, students, and then help you to form how this frequency distribution. Okay, the problem is very simple here. You can see here, it is there on the screen. Okay, I'm just um, okay, enlarging it for you so that you can understand it. Okay, fine. Is that clear? Right. See here. The data given below relate to, okay, the data given below relate to the height and weights of 20 persons. The heights and weights of 20 persons. Construct a bivariate frequency table with class intervals for height as 115 to 125, 125 to 135, and so on. And for weights as 62 to 64, 64 to 66, and write down the marginal frequency distribution of x and y. They have mentioned it. Okay, so now this is the data that we have it here, students. Okay, so you have understood the data, right? Now what we need to do is, let's find out in this is all about 20 people. 20 people, their heights and weights are given to us. The first person height is 170 centimeters, weight is 70. Second person's height is 135, weight is 65. So like that, all the data is given about 20%, students. Okay, and they have also mentioned here very clearly. They have mentioned that the class intervals for height we should start from 115 to 125, 125 to 135, like that. And for weights we have to start from 60 to 64, 64 to 66, and so on. This is how we have to find. Okay, so now a table is ready for us. So we will, what we do is, let's identify first. Okay, first, once you identify certain values, then it will be easy for us. So I'll take the first variable is heights. For heights, let us start with what is the maximum value. What is the maximum value for heights? Okay, what is the maximum value for heights? Let's identify that. Then it will be easy for you to understand. Okay, maximum value for heights. So the maximum value for heights that is something as, let's check it out here. In the first row it is 170, and in the second row it is not crossing 170, so 170 is the maximum value, okay, of heights, 170. Then what is the minimum value? What is the minimum value? Let's see what is the minimum value. Not necessary for this particular problem, but still let's identify what is the minimum value. In this 170, 170, 121, 117 is least in the first row, and that's it. 117 is the last least value, 117. Okay. The next, for weights, students, for weights, okay, uh, let's see what is the maximum value. What is the maximum value? Let's see in that, in the second here, in the weights. 70, 60, 65, 70 is greater here, 70, 71 we see here, then 71, nothing above 71. So the maximum value is 71. Okay, and the minimum value is, how much it is? It is here, if you see here, the minimum value is 63, 62. Okay, 62 we've seen. Okay, then we have in this is nothing less than 62. Okay, so 62 is the last least value in the weights. Okay, so now let's start writing it here. So what I will be doing it here is, I will denote, right, heights as x, and I'll denote weights as y, students. Is that okay? Fine. Okay. So what I'll do is, I'll diagonally write it here as x. All the x will be in the rows, and all the y's will be in this. Is that okay? Right. So let's see what it is. They said x. They said the columns should be like this, students. Okay, the heights should be in this way. It should start from 115 to 125. Okay, so they said this. Okay, right. Then we have what it is next is 125 to 135. Okay, then 135 to 145, 145 to 155, 155 to 165, 165 to 175. I'll end it here. The reason is 170 is the last value, so the last column would be total rows. Likewise, in the heights will be y. So the start would be for me, as they said, 62 onwards. They said, is it right? 62 onwards. If you just go back and see here, they said 62 to 64. Is that right? So I'll start here as 62 to 64, 62 to 64, then 64 to 66, 66 to 68, 68 to 70, and 70 to 72, and the last column would be for me as total. Okay, so I hope you have understood this, students. So let me start doing this, so it will be easy for you in a different color to understand the tally. Okay, the first, right? I'll start with the first number. First number is 170. Height is 170. Height 170 comes in the last column, students, and the weight of that person is 70. The weight of that person is 70. That comes under 70 to 72. Last column, 165 to 170 is his height. That is 70. 170 is his height, and 70 is his weight. So this is the cell which is common to his heights as well as weight. So I'll put a tally here. I hope you understood here. This is the tally. So I will say this is red. I'll continue the problem, students. Okay, I'll continue this, doing this. Now this is what is we have already read. Now the second person height is 135 and his weight is 65. 135 comes in this column, in this row, students, 135 to 145. and his weight 65 comes in this column, that is, so I'll mark a tally here. So this also, the second person's also is red. Then 136, 65. 136 comes under 135 to 145. 65 again comes here. So this also is red, students. Then 137, 64. 137, 64 the same place. 137, 64. Then 148, 69. 148, 69. Here it is. Okay. Right. The fifth person also is red. Then 121, 63. 121, 63. Here it is. Okay. Then 117, 65. 117, 65 is this here. Then 128, 70. 128, 70. Okay. Then next is 143, 71. 143, 71 is this. Then the next is 129, 62. 129, 62 is here. So 10 of the person's data we have already entered. Now the 11th person's data. 163, 70. 163 comes here in this 155 to 165, and 70 is here in this class. Right, so this is 11th person's data also is red. 12th person's 139, 67. 139 and 67. Okay, so this also is red. Then 122, 63. 122, 63. 122, 63 is this. Okay, then 134, 68. 134, 68. We get it here. Then 140, 67. 140, 67. Then 132, 69. 132, 69. 120, 65. 120, 65. 148, 68. 148, 68. Then 129, 67. 129, 67, students. The last one is 152, 67. 152, 67 comes here. 152, 67. So all the 20 values we have read, and whichever cell that you find is empty, we have not entered, just put a dash, students. Just put a dash. It is according to the rules of tabulation. If we don't find any data, we need to write either NA, not available, or a hyphen like this, a dash, which says that the data is not available for these cells. So now, let's add up the tallies and write row wise. 2 plus 2 is 4, students. This is 4. Then 1, 2, 3, 4, 5. This is 5, students. Okay, and that is 5. Then 3 plus 2, 5 plus 1 is 6. This is 6, students. 1 plus 2 is 3 here. And this is 1. And this is 1. Is it right? So when we add up, we get as 20. Right? 9 plus 6 is 15. 15 plus 5 is 20. Likewise, in the column wise also, we see when we add this, 2 plus 1 is 3. Then here we have 5. Then we have here is 4. Then here also we have 4. Then here also we have 4. So this 20 is what we call this to be as for us n, and in other words, it is the total frequency. Total frequency. Okay. So now, students, when it comes to this part, okay, so when we are doing this, so they have asked us to find out the marginal also, students. Marginal. Okay. So they said marginal. So when they said marginal frequency distributions of each variable. So for example, they asked marginal frequency distribution of heights. When they said heights. So what we need to do is heights we are denoted as x, and what are the values that we have it here is 115, right, to 125. Then 125 to 135, 135 to 145, 145 to 155, then 155 to 165, 165 to 175. Is it right? Then we have to write the frequencies of each. That is, for 115 to 125, the frequency is 4 that we have it here. 125 to 1, the total frequencies we have 5, and this would be 6, this is 3, this is 1, and this is 1, and total is n is equal to 20. So this is how we write the marginal frequency distribution of heights, students. Okay, so likewise we also can do it for weights. We also can do it for weights. Okay, so marginal frequency distribution of weights. Marginal frequency distribution of weights. So weights variables we denote it as y. Is it right? We denote it as y. What are the values of y? That is 62 to 64, 64 to 66, 66 to 68, 68 to 70, and 70 to 72. Is it right? So what are the frequencies for it? If you speak about 62 to 64, the frequency is 3, and for it is 5, and for this it is 4, this also it is 4, and this also it is 4. So the total is n. So this is what is marginal frequency distributions. Okay, so I hope you have followed this, students, and this is what we call it as bivariate frequency distributions. And these type of bivariate frequency distributions we come across in problems like correlation, regressions, and all, students. Okay, so I hope you have followed this. If you haven't followed, please go back and watch the video, or if you haven't still understood any of that, I think you can just give me a call or text me. It would be nice of you, and I will explain all that in detail. Okay, thank you.